In this video, we're going to be looking at finding the nth term of an arithmetic sequence. Before watching this video, you need to be really comfortable with two topics. The first one is topic A24b, which is all about being able to identify special types of sequences, which includes arithmetic sequences. So you really need to understand what they are and know how to recognize them. And the second topic you really need to be comfortable with is topic A23a, and in particular part 2 of that topic, which is all about generating a sequence given an nth term formula. And we'll quickly recap that here. So here's an example of a question that you should be comfortable answering before watching the rest of the video. So pause here and have a go. What you should have found is that the first term is what you get when n is 1. The first term is when n is 1, and that means it is 4 times 1 plus 1, which is 5. The second term would be what you find when n is 2. The second term, 4 times 2 plus 1, and that's 9. The third term is what we get when n is 3. 4 times 3 plus 1 is 13. And carrying on, you should have found 17 and 21. If you're not sure about this at all, go back to A23a. A really important thing to note is that this sequence is going up in steps of 4, and that is the same as the coefficient of n in this nth term formula for the sequence. And that's not a coincidence. In fact, we're going to use this to help us answer the types of questions where we get given a sequence like this, and we have to work backwards to find the nth term formula for that sequence. In fact, let's take a look at how we would do that. Let's say we were given this to start with. How would we find the nth term formula for this sequence? Here I've got the same sequence we've just looked at, so we know the answer is going to be 4n plus 1, but let's see how we actually go about working that out. The first thing I would do is notice what the sequence is going up in steps of. So in this case, it's going up in steps of 4. Now, what is the simplest sequence that goes up in steps of 4? Well, that is just the 4 times table. So I'm going to write the 4 times table directly underneath this sequence. Here's the 4 times table. Let's just concentrate on this red sequence for a second. The first term of this sequence is just 4 times 1. The second term is 4 times 2. The third term is 4 times 3. The fourth term is 4 times 4. So the nth term would be 4 times n. This is simply the sequence whose nth term is 4n. So that is the nth term of this particular sequence. And we can just check this works. The first term of this sequence, remember, is what we get when we substitute 1 into here. 4 times 1 is 4. The second term is what we get when we substitute 2 into here. 4 times 2, that's 8. And there we go. So the nth term of this sequence is 4n. But we're not actually looking for the nth term of this red sequence. What the question is asking us for is for the nth term of this sequence up here. But hopefully you can see that this sequence is just the red sequence with 1 added on to each term. So what we actually have as the nth term of this sequence is simply 4n plus 1. And there we have it. That's the answer. That is the nth term of this sequence. Let's just check it works with these. Let's take, say, the third term. If n was 3, we'd have 4 times 3, which is 12. That's that number there. And then we need to add 1, and that would give us 13. So it works when n is 3, and in fact that's going to work for any particular value for this sequence. This sequence is simply our 4 times table shifted up by 1. Here's the next question. I'm going to start off answering this question, but then give you a chance to pause and complete the rest of it. Again, we're looking for the nth term of a sequence, and what I'm going to do first is look at what this sequence is going up in steps of. Just like our previous example, this is going up in steps of 4, and that means it's like the 4 times table. The 4 times table is the simplest sequence that goes up in steps of 4. So what I'm going to do is write my 4 times table directly underneath these, starting from 4 times 1. So that's 4, 8, 12, 16. Now we know that the nth term of this sequence, the nth term of the 4 times table essentially, is 4n. Now you have to work out what we're doing to the 4 times table to turn it into the sequence we were originally given. Pause the video and see if you can work out the nth term of that sequence there. Hopefully you've spotted it. All we're doing is adding 4 to each of these terms. 4 plus 4 gives us 8, 8 plus 4 gives us 12, 12 plus 4 gives us 16, and so on. So this sequence up here is simply our 4 times table, that's 4n, having had 4 added to it. So we need to put a plus 4 on the end. So the nth term of that sequence is 4n plus 4. Again, we can just test out this works. Let's try the second term. The second term should be 12. So if we substitute 2 into here, we should get 12. 4 times 2, that's 8. Plus 4, yes, that gives us 12. Here's the next example. This one is not going up in steps of 4, so it's not like the 4 times table, but it is going up in steps of 3. So it's like the 3 times table. Pause the video and have a go at this one. Here's what you should have got. Writing the 3 times table directly underneath these, you would get 3, 6, 9, and 12. The nth term of this sequence is simply 3n. Remember, the first term is just 3 times 1, the second term is 3 times 2, the third term is 3 times 3, the fourth term is 3 times 4, so the nth term is 3 times n, or 3n. Now, what's happening to this sequence to turn it into the one we're actually interested in? Well, hopefully you can see we are adding 7 to each term. And that means the nth term of this sequence is simply 3n plus 7. And that is the nth term of this sequence. Here's the next example. We need to take a bit of care with this one. This sequence is going down in steps of 2. Now, it's not like the 2 times table, because the 2 times table, 2, 4, 6, 8, and so on, is going up in steps of 2. The simplest sequence that goes down in steps of 2 is actually our negative 2 times table. So what I'm going to do is write the negative 2 times table underneath here. We've got negative 2, negative 4, negative 6, negative 8, and so on. The nth term of this sequence is simply negative 2n. Remember, the first term would be negative 2 times 1, which is that. The second term would be negative 2 times 2, which is negative 4. The third term is negative 2 times 3, which is negative 6, and so on. So that's our negative 2 times table, which is, in a sense, the simplest sequence that goes down in steps of 2. And what's going on here? To go from negative 2 to 21, what I've actually got to do is add 23. And if you check out all the others, to go from negative 4 up to 19, what I've got to do is add 23, add 23, add 23. So that makes it clear that the nth term of this particular sequence is negative 2n plus 23, which is taking this sequence and adding 23 to each term. So the nth term of this sequence is the same as the nth term of this sequence, but with 23 added onto it. Here's one for you to try for yourself. Here's the answer. This sequence is going down in steps of 5. So I'm going to write my negative 5 times table underneath. Negative 5, negative 10, negative 15, and negative 20. This sequence is going down in steps of 5. And the nth term of this sequence is negative 5n. Now, what's going on? Well, to go from this sequence to this one up here, what we have to do is add 9. Negative 5 add 9 gives me 4. negative 10 add 9 gives me negative 1, negative 15 add 9 gives me negative 6, and negative 20 add 9 gives me negative 11. So we are adding 9 to each term of this sequence to get the corresponding term of this sequence up here. So the nth term of this sequence up here is simply negative 5n plus 9. Here's our last example. Pause the video and have a go at this one. Here's the answer. What you should have spotted is that this sequence is going up in steps of a half. So what I need is the half times table. And that's simply a half, then 2 lots of a half is 1, then 3 lots of a half is 3 over 2, 4 lots of a half is 4 over 2, which is the same as 2. And the nth term of this sequence here is simply a half n. Now, what's going on to go from here to here? Hopefully you can see we're simply adding one whole. A half plus a whole, which is the same as 2 over 2, gives me 3 over 2. 1 plus 1 whole gives me 2. 3 over 2 plus 1 whole gives me 5 over 2. 2 plus 1 whole gives me 3. So the nth term of this sequence is a half n plus 1.